Hey there students, welcome to the top of Mathematics Mountain. We're here today to talk about exponential graphs. Now, here's the dot point from the syllabus. We've got to be able to recognize exponential graphs in this particular format, so y equals a to the power x, where a is greater than 0. But we've also got to be able to identify any asymptotes and also talk about the effects of different changes to a function that might cause different transformations, including translations. But we'll talk about those a little more in class. For the time being, let's have a look at plotting the graph of f of x equals 2 to the power x, which is probably the most basic exponential function going. So we want an output of 2 to the power x for each of these inputs of x up here. If we start off with 0, 2 to the power 0 is equal to 1, because anything to the power 0 is 1. 2 to the power 1 will give us 2, then 2 to the power 2 will give us 4, and 2 to the power 3 will give us 8. And because we've got f of x equals 2 to the power x, if we carried on by increasing our x values by 1, it would be doubling each time. So 8, then 16, then 32, and so on. We've also got to contend with what happens when we have a negative for an input. So if we have 2 to the power negative 1, that's the same as 1 over 2 to the power 1, or just 1 over 2. If we continued that a little further, 2 to the power negative 2 is the same as 1 over 2 to the power positive 2, so 1 over 4. And then that pattern would continue as we moved further and further to the left. So then we'd go 1 over 2 to the power 3, which is 1 over 8, then 1 over 16, 1 over 32, and so on. So let's go ahead and plot these. And I'm sort of doing a bit of an artist drawing on an easel sort of situation. So I'll do my best to make it neat. We've got 0, 1, 1 and 2, 2 and 4, 3 and 8. And going in the harder to draw direction, negative 1 and a half, negative 2 and a quarter, negative 3 and an eighth. And I'm going to do my best to do a neat-ish function. That's not bad, Mr. Barker. Well done. A budding artist in the making. Okay, now I've included a couple of key questions for us to answer. So number one is, what is the coordinate of the y-intercept? So looking at the graph, when x was equal to 0, we identified that the output for that has to be 1, because anything to the power 0 is 1. So that's kind of a key takeaway for this one. If we had, say, f of x equals 3x, and we're finding the y-intercept, 3 to the power 0 is still 1. If we had f of x as, 10 to the power x, the y-intercept would still be 1. If it was a million to the power x, it would still be it'd still be 1 when x was equal to 0. So that's a key thing. If we've got a sort of pretty basic looking exponential function such as this one, that's something to keep in mind, that unless it's undergone some sort of transformation, your y-intercept for this sort of thing is always going to be 0 and 1. So that's a key bit of knowledge that we'll build upon tomorrow. And then the next part is, what is the equation of the asymptote? So if we look at this area of the graph here, we notice that as x gets smaller and smaller, our y value is going to get closer and closer to 0, because that fraction is going to get smaller and smaller. So an eighth, a 16th, 1 over 32, 1 over 64, and so on. But it's never actually going to arrive at 0. It's going to get really close as x gets larger, but it's not actually going to get there. So that means that our asymptote is going to be at y equals 0. And similarly, if we've got a pretty basic looking exponential graph, like y equals 3x, for example, that's not had any other transformations applied to it, your asymptote is always going to be at y equals 0. And that's something important to keep in mind before we do the transformations tomorrow. And then lastly, what is the domain and range of the function? So if we consider the domain first, we will have a look at this. We could go, if we went towards negative infinity, all of those values are going to become part of our function. Same for going to positive infinity as well. So I'm going to write that as negative infinity and positive infinity. By the way, if you're using this sort of notation for your domain, make sure that you use a regular parentheses type bracket instead of a square bracket, because square bracket means that it includes whatever you have as part of your coordinate there. And we can't say that it includes infinity. It's just going to approach infinity. It's not a concrete number that we can actually arrive at. It's more of an idea, man. You know what I mean? And then for a range, something similar happens. It's going to approach 0 as we go closer and as our x value gets smaller and smaller, but it's never actually going to get there. So that's why we're going to use the parentheses rather than the square bracket, because the square bracket would mean that it includes 0, which it doesn't. And we're going to go from 0 up to infinity as our range. Okay. There's a bit of a cold breeze blowing across the mountain at the moment. Let's warm things up with a second example. So in our first one, our exponential graphs will look like that when our value for a is greater than 1. The other situation we've got to consider is when a is between 0 and 1. So if we plot the graph for this real quick, let's take this as our function here. So g of x is equal to a half raised to the power x. So like before, if we did a half to the power 0, anything to the power 0 is 1. So that's an easy start. Now, if we did a half to the power 1, using our index laws, that's equivalent to 1 to the power 1 over 2 to the power 1, which is just the same as a half. If we did 1 over 2 and raised it to the power 2, that'd be the same as 1 squared over 2 squared. 1 squared is still 1, and 2 squared is 4. And if we continued in that direction, we'd see a similar sort of pattern emerge. So we've got 1 over 8 would be, 1 over 2 to the power 3. So 1 over 8, and then 1 over 16, 1 over 32, and so on. And what we find is if we go to if we look at the values on the left-hand side of the table, so let's say 1 over 2 to the power negative 1. Again, I'll use my index laws again. So 1 to the power negative 1 over 2 to the power negative 1. That'll give us 2 over 1, which is just 2. Similarly, if I raise that to the power negative 2, we'd get 1 to the power negative 2 over 2 to the power negative 2, which would be 2 squared over 1, which is 4. So then we get 4. If we did it again, we'd get 8. If we did it again for negative 4, we'd get 16, and so on. So a good takeaway to keep in mind there is that we've got some symmetry between the graph of our first one. So f of x is 2 to the power x, and g of x, which is 1 over 2 to the power x. So that's something important to keep in mind for the next couple of lessons. Let's just plot this real quick for fun and to close out the video. So we've got 0 and 1. We'll go 1 and a half, 2 and a quarter, and then 3 and an eighth. Going the other way, negative 1 and 2, negative 2 and 4, and negative 3 and 8. Right, let's join those up as best as we can. Oh, it's not bad. I think that will be okay. The maths police, I don't think, will arrest me for that graph, so let's keep it like that. Okay. Let's have a quick look. So following on from the previous section, the y-intercept looks like it's going to be the same. So 0, 1. And again, if we transform this graph in some way, that might have an impact on that. Another thing to keep in mind for tomorrow. The equation of the asymptote, we're still at y is equal to 0. So again, without any transformations, still at y equals 0. Keep that in mind as well. And then for our domain and range, looking at that, our x values look like they could go from negative to infinity to positive infinity. And for our range, let's have a look at our range. Okay, so even though it's flipped around a bit, it's still going to approach 0 at the lower end. It's going to the right this time, and it's going to approach infinity as our x values get more negative. So we're actually going to have the same range as last time. We're going to go from 0 to infinity, not including 0 or infinity. Okay, so in class we're going to have a look at the impact of transformations and use that knowledge to sketch exponentials as well. But that's a story for another time. Thanks for watching.